In this project, we will learn how to control an LED with a push-button switch. Essentially, when the push-button switch is pressed, the LED will light. It will continue to stay lit when the switch is engaged, and once it is released, the LED will go out and stop being lit. Let's take a look at the objectives for our project. By successfully completing this project, we will have mastered the following items. You will understand how an LED works, how to wire an LED in a circuit, how a push-button switch works, how we connect a push-button switch in a circuit, and finally, how to use the digital read function for Arduino. If you're ready to begin, let's get this project started. Here are the parts that we will need: an Arduino Uno, a USB cable, a breadboard, a red LED or any other color of LED that you may have, a 220 ohm resistor and a 1 kilo ohm resistor, a push-button switch, and connecting wires. Let's take a look at our circuit diagram that we'll be using. For the Arduino, as you can see, the ground connection and the 5 volts are connected to the ground and 5 volt rails on the breadboard. For the LED, the cathode or the negative pin of the LED is connected via a 220 ohm resistor to ground, whereas the anode or the positive pin is connected to pin 8 on the Arduino. For our push button switch, one end of the switch is connected to the ground rail. The other end of the switch is connected via a 1 kilo ohm pull-up resistor to 5 volts, and the other end of the switch is directly connected to the pin 7 on the Arduino. Let's wire up this circuit. The first thing we'll do is let's connect the ground and 5 volts. So on my Arduino, I'm going to go from ground, the ground pin, to the ground rail. And next, from the 5 volt output to the 5 volt rail on the breadboard. Next, we can connect our LED. Now, for an LED, you'll notice that there is a shorter pin and a longer pin. The shorter pin is called the cathode, or it's the negative pin, and the longer pin is the anode, or the positive pin. For an LED to light, electricity has to flow into the anode and out of the cathode, right? Because an LED conducts electricity in one direction only. Okay, so let's wire up our LED. If you look at our circuit diagram, we have a 220 ohm resistor that is connected from our cathode directly to ground. So let's go ahead and wire that up. We have our LED. Next, we're going to connect our 220 ohm resistor to ground. And from the anode of our LED goes to pin 8 on the Arduino. So I'll make that connection now. Next component we wire up is our push button switch. And if you look at a push button switch, the particular one that I have, there are a couple of connections on this side. Once the switch is engaged, current can flow through the circuit between these two actual connections here, and similarly on the opposite side of the switch, when it's pushed or engaged, current flows between these two connections here. So let's go ahead and connect that switch in our circuit. If you look at our circuit diagram, from our switch. One end of the switch goes directly to ground. Let's make that connection. And then we have a 1 kilo ohm pull-up resistor connected to 5 volts from the other end of the switch. So we'll go ahead and make that connection here. Okay, directly, as you can see, from the other end of that switch to the 5 volt rail. And the final connection that we have to make is actually from that same end of the switch. And we're going to go to our Arduino on pin 7. Alright, so that completes the wiring for our circuit. Let's go ahead and upload the code and test this out. So I'm going to connect the Arduino. Here we go. And upload our sketch. Once that is complete, let's test it out. When you press the push button switch, our LED lights. So there you have it. As long as the switch is pressed and engaged, the LED stays lit, and as soon as we move our finger from the switch, the LED goes out. There you have it. You're now controlling an LED using a push button switch and the Arduino. Let's take a look at the code for our project. At the beginning, we do some initial configuration. We define the LED pin as 8 since it's connected to pin 8 on the Arduino. And then we define the button pin as 7 since it's connected to pin 7 on the Arduino. In our setup function, we set the LED pin as an output pin and the button pin as an input pin since we'll be taking our readings at the button pin to determine if the button is pressed or not. Our loop function is fairly straightforward. Here we'll use the digital read function and read the value at the input pin. If that's low, that means that the switch is pressed, and if that's the case, we'd want to turn our LED on, so we use the digital write function to turn the LED pin high, and the LED will be lit. If we do a digital read of button pin and it's high, that means that the switch is not being pressed, and we would set the LED pin to low and it would turn off. Just a reminder, here on our circuit diagram, in its normal state, as you can see, if we take a digital reading at this pin, it would be 5 volts or high, since it's connected via the resistor to the 5 volt rail. When the switch is pressed, however, current is going to flow through the resistor down to ground, and if we were to take a reading here at this point in the circuit, then it is shorted to ground, hence that reading would be low or 0 volts. So hopefully that explains how the push button switch is used in conjunction with the resistor and the Arduino to turn our LED on and off. To summarize, in this project you learned how an LED and a push button switch work and how they are connected in a circuit. You were also introduced to the digital read function for taking an input reading. These are basic components that are common in many electronics projects. You now have gained an understanding of how they work and can incorporate them in any of your future projects.